Hi, welcome to the first in a series of tutorial videos for the Precision Sustainable Ag team, explaining how our different protocols work and how you can use some of the tools that we've built out. I'm Brian Davis. I'm one of the data managers for PSA, and in particular I specialize in data visualization. Of course, you can't visualize data until you have access to the data. So in this series, we're going to talk about how you access the PSA on-farm database. This is going to be a four-part series where we talk about sort of database 101, how to get set up, running a local database, and then finally accessing our production database. If you are familiar with databases, you probably don't need all of those parts and you can skip to the end. But of course, hopefully there will be interesting material in all of these for you. Accompanying this video series, there is going to be some web pages that have all of the code that I'm going to be using, as well as much more in-depth explanations of everything I'm going over. So these videos are kind of an interactive explanation, but if you want to know more details, again, go to the web page. In addition, these web pages are R notebooks. R is a statistical programming language, which is what this series is going to focus on. And you can use these notebooks to run the code on your own computer interactively and see the explanations and the output in the same document. This is all stored in a GitHub repository, which I'm going to show you in just a second. So let's get right into it. Here you can see that I am in the repository for this project, Database Querying R, in the Precision Sustainable Ag team. You can see the URL up here. And there's a lot of files in here. We'll go over what all those are. But you can see in this README document a little bit about it and links to the 4 notebooks that are going to be in this tutorial. So let's go ahead and get started with number 1. What is a database? A database is a lot like a spreadsheet. It's a rectangular storage system, rows and columns of data. However, unlike Excel or Google Sheets, it has a lot of limitations about what can go in different columns, what can go in the rows, basically rules that are set up when you design the database to make sure that your data is cleaner, to make sure that accessing it is easier, and then also these systems can be deployed on much larger scales than, for example, some Excel sheet that's on your computer or even a Google Sheet. You can have databases that have millions and millions of rows as opposed to just, a few thousand for a spreadsheet on your computer. The language that you use to interact with a database is called SQL, the structured query language. This isn't some new thing that you have to learn. There are a lot of tools that sort of translate commands that you would already use in R into SQL, or if you're using Python or SAS, they're kind of equivalents. But if you know SQL, there are certainly ways in R to send those commands through to the database. So the database in general is usually thought of as having a server, which is a computer program that hosts the database, and clients, which are computer programs that access the database. Servers and clients can be on the same computer together, and we're going to talk about that in the third part of this tutorial, a local database. But they can also be on a web server, which is the case with the on-farm database. So what makes a database interesting is that you sort of pre-design a lot of details about it. So each column can only contain one type of data. So for example, numbers or text or dates. The type of column has to be decided before you put any data in, and there's nothing outside the quote-unquote rectangle. So let me give you an example of what I mean by the rectangle. So this is a badly formatted Excel data sheet. So you see we've got 2 rows of headers We've got these ambiguously formatted dates in this column that are just text. We've got information that is encoded as highlighting. We've got charts that are floating around. We've got a pivot table that's floating around. You can see that there was an entry error with this cell, that it should have been 1.1.20, but instead it was typed in and it was converted to a date internally, so it's just represented differently. You can see there's some sort of pop-up information on this one, but it's sort of hidden. You can see that there's bag missing written in this column, which should be only numbers. You can see there's also this dot, which presumably means that the sample is missing. Again, that column should be only numbers. So if you were to convert this into a database, you would have to fix all of those issues. There are some additional benefits that go along with these restrictions. So because you already know what kind of data is going to be in an individual column, you can make it much more efficient. You already know that it's pre-cleaned, and you've basically dealt with all of those problematic parts of your data before you get it into the database. So these additional benefits are usually around the fact that you want to store a minimal size table for each table in the database. And so each table will then have a key that connects it to other tables. So, for example, the plot number that I just showed in the badly formatted Excel sheet, that same plot number would be used in another table, and then you could connect those two bits of data. So using these keys can map, one row to another row, many rows to one row, and planning out all of this structure really helps you decide how to organize your data, which again makes analysis, modeling your data much more efficient. The big downside to using a database is you have to learn how to use them. It's not just an Excel sheet on your computer. But there are a lot of things in R that sort of make it look as close to that as possible. So let's look at a toy database that I've made up here. It has two tables. One of them is treatments and one of them is yields. You can see there are three columns: plot ID, crop and tillage, plot ID, and megagrams per hectare. These are nicely formatted. There are no errors. We can see that there's only one type of data in each column, etc. But if you wanted to do an analysis on this, and if you were making a spreadsheet locally, you'd probably want all of this in one single table so that you could associate, you'd have plot ID, crop, tillage, and yield all in one row. However, I don't know if you've noticed this, but I certainly have. When you're making lots of these sheets, so for example, you have one for weed ratings, and you have one for crop yield, and you have one for cover crop biomass, you always end up with some copy-paste errors and things like that that you have to go back and clean up. And so just having this one table for treatments that then you can subsequently join to all the other metrics that only have plot ID and what the metric is really helpful. So basically, what that all boils down to is a database is a collection of really well structured data tables that connect to each other via some relational means of a key. And we will talk about how you would get one installed on your local computer and how you would access the OnVarm database in the next tutorial.